And if you like what you hear, we're always willing to host one-on-ones with individual organizations where we can maybe get more in depth, have more conversations, tailor it to your individual needs. So please don't ever hesitate to reach out to me directly and get that set up. So I'll cover the agenda real quick and I'll turn it over to our CEO, Bill Tennant. So we're going to do a quick introduction to Sniffer Robotics and our technology. I guess you might call that our timeshare pitch, but it will be brief. Then we're going to do an overview of methane detection technologies and the differences between compliance and emission studies, and that's critical. That's really the crux of what we're here to talk about. What's different and why would you do one versus the other? And we'll go into the top 10 reasons for voluntary emission studies, and then talk about the return on investment. And so I think it's natural to think if you have a gas collection system or RNG system, the return on investment is pretty obvious, but it's actually there for landfill operators as well, and we'll cover that. And we'll talk about our partner program, which enables a partner to get access to our sniffer drone payload, where they could fly their own missions. And from there, we'll close it out. We'll do Q&A and any discussion. We'll cover that at the end. So without further ado, I will turn it over to Bill Tennant.
Greetings, everybody. I'm Bill Tennant. I'm the CEO of Sniffer Robotics. First thing I just want to talk about is a little bit about Sniffer. We were founded originally in Ann Arbor, Michigan. Currently, I'm based out of Atlanta. We have people, as you see, spread across the United States. Last year, we flew missions in 120 distinct sites in 40 states. We also flew numerous, like about 20 sites or so in Canada with our partners up in Canada. We're flying now currently in South America, in Argentina, and we're starting work in Brazil in March, and literally starting work in Europe, which we have to update the slide with Europe on here now. We're going out to Spain and France next week to start operations in France. Why is that? Well, that goes back to the fact that our payload now has been refined well enough to where we can hand it off to third parties to fly, which is the partnership program. And also because we have the US EPA certification, we have some both scientific and regulatory backup to say that, yeah, this works. So there's some credibility. Along the bottom, you can see, the who's who of the different companies we work with. It's not all, but it's a good list of them. And we also partner with Project Canary, which is an advanced air modeling company. We provide them with the data from our drone, and they use their air modeling to provide us emissions rate calculations. So that's kind of just an overall summary of what we do and who we are. Is Chris Scully on?
No, it doesn't look like he made it.
Okay. I was going to give an opportunity to talk. We just signed another partnership agreement with Del Mar and Perspectum. They're two companies, but they're one's a subsidiary of the other. Del Mar Aerospace is based out of Las Vegas, but they have offices across the West Coast, and they're helping partner with us to help us cover the West Coast more efficiently. And Perspectum is in Canada, and they are our primary partner in Canada, and they're the ones we've flown in multiple missions up in Canada with already. So that's a really good thing for us, but also for clients, because the biggest part of our cost is mobilization. We have to mobilize to get to the site. And by having partners that are more regional and more local, those costs go down, which allows us to be more efficient for you. So I'd like to talk about the state of technology right now. But I want to make sure you understand that there's a strict divide or moat between what's done for compliance and what's done on the emission study side. That's why we put big red box around it, okay? If you're at a landfill in the United States or actually in Canada, and you need to do your quarterly surface monitoring, there's two methods. The US EPA method 21, which is a guy walking and doing the surface emission monitoring. The other option is US EPA alternative test method 51, which is currently provided by Sniffer, the Sniffer drone. Okay, and what those allow you to do is do your core surface and monitoring, and then you have to do your body, your rechecks and all that kind of stuff, and you submit a report. What's critical though is there's a lot of other technologies out there that are being used for non-compliance emissions work to help people improve their gas collection. So sometimes because we have the EPA approval, people think sniffer drone equals compliance and everything we do is compliance data, and that's just not true. The sniffer drone is a data collection tool, and it's a very good and very precise data collection tool, but it's not compliance in and of itself. You have to follow the very strict guidelines laid out in other test method 51 in order for it to be compliant. Just like if you have a SEM 5000, just using it doesn't make compliance, but when you do method 21, now it's in compliance with this exact same thing. Right, so let's talk about some of the other things. The sniffer drone is good in that we can do both localization and identification of link locations, but we can also do emissions rate quantification, as I mentioned, by partnering with Project Canary. Another technology out there that does localization is the TDLAS laser, which shoots a laser down through the plume and then uses that data to calculate the locations of emissions. One issue with them is that their unit of measure is parts per million meter, which is not the same as parts per million. And there's some other issues, but that's out there. And then you have some airborne platforms, either plane helicopter mounted satellites that are looking down and providing emissions rate quantification. And then you also have some fixed sensors and other drones that are doing quantification work. And the fixed sensors are nice because they're giving you a 24/7 look. And if something changes, then you can come out and do some more detailed inspections. It's a general overview of what's out there at the moment. And we can talk about that if people have questions about it. A little more specific about us. We don't build the drone, we build the payload. So the sniffer drone payload is the green box. It mounts on an M300 or an M350 DJI airframe. We currently are in the process of updating our flight control software, and we will be mounting it on the M400 as well, which is now commercially available in the United States. As configured in the picture, you get about 30 minutes of flight time. If you take the camera off and use onboard cameras, you can get another 5 to 10 minutes of flight time for the released weight. And then the drone itself has a high-powered laser that's used for active terrain following, not for methane detection, and an external readout that allows you to do error controls when you're starting up the system, and some other features there as well. So that's in general the payload. One thing about the payload, the sensor is accurate down to 200 to 250 parts per billion. That's significant because your normal walking SEM or your other equipment that you use is typically, in the parts per million range. So it's a lot more accurate, and we never read zero. So when you get a report back, the minimum we're going to read is about 2 parts per million because the ambient air across the world is 1.8 to 1.9 parts per billion. Okay, so here we are. This is what it looks like when it's flying. We joke around that it's the stupidest drone on the planet because you're literally flying a drone and then you are dragging a hose on the ground, which is kind of counterintuitive. But there's a reason that we did that. It is designed to mimic Method 21, just using a drone. So when we talk about doing compliance work, OTM 51 equals Method 21, almost word for word across the board. And that's why we were able to get US EPA approval for compliance. If you watch the nozzle, I always like to tell people, watch the nozzle, and you can see that it's dragging on the ground, but it's not bouncing around too much. And the nozzle is always pretty much on the ground. And the end of the nozzle is bent up slightly, so it always keeps the sample portion of the nozzle 2 to 4 inches off the ground. Now, in some states, they require you to measure it 0 to 4 centimeters off the ground, 0 to 2 inches off the ground. We also have a non-bent version of the nozzle for those states. But the key here is that the laser on board the payload is querying the ground about 1 million times per second. It's constantly doing the altitude adjustments to keep the drone 6 meters off the ground, and that's what keeps the nozzle on the ground. And then the flight paths are controlled by GPS, and there's active flying as well because see right here he's going by a well. If he had to veer, if the path went right through that well, he would have manually flown drone to the right and veered off path, and as soon as you let go of the sticks, it's going to snap right back on that GPS path and continue on to it. So very precise and very accurate and very controlled. This is kind of an example of what it would look like, from start to finish on the flying. The left-hand side is the flight paths. We designed the flight paths based off the amount of battery life we have, but also we have to keep line of sight with the drone at all times. So that's done prior. And then when you fly it, you can see that lo and behold, yes, it looks almost exactly like the flight paths because it's controlled by GPS. I think the key to notice, and I'm sure you've seen snail trails from someone walking. They're not as regular because the guys are avoiding obstacles or whatever. And the space between these data points isn't equal. But we also are able to put geospatial buffers on every single point. So if we're flying a 15-meter study, we're going to put a 7.5 meter geospatial buffer on either side of that point. And as long as the points overlap and we don't have any white spaces in there, we know we got 100% coverage on the surface overall. So, and there's a quality control of that because before our technicians or pilots leave site, our GIS technicians, in the eye in the sky is looking at the data and making sure that any gaps are filled in, or if they can't be filled in due to operations, that we're getting a comment to put in there why that area wasn't filled. Talked about, spacing of points. You can see the spacing between paths is very equal because of GPS, but the space between each data point is also very uniform. The drone is flying at 7.5 miles per hour. You're taking 3 readings per second, and therefore you're getting equal spacing between data points. Typically 1 meter to 4 feet between data points is the normal. There might be, like when it turns, the drone slows down slightly, so it'll be a little bit tighter data collection in the turns, but other than that, it's very uniform across the surface of it. And we also have the 4K camera on board, so as we're flying, the pilot's watching. First of all, looking for obstacles as they fly, but second of all, looking for other issues, erosion rills. You can see down here, you've got distressed vegetation, erosion rills, torn geomembrane, and they'll take pictures of all that. And then they'll geolocate those, and those will be checked as well to make sure that there's no emissions coming from there. And this is kind of the whole process. And fly it in panel 1 with flying. Panel 2, you can see once the drone is coming back for a battery change, the pilot will hit send to the data on the remote. That data gets shot up to AWS and into ArcGIS, and automatically peak locations show up in the app and in the software. That's basically showing you a location where there's either 200 parts per million if it's yellow or 500 parts per million where it's red. And then if we were doing compliance work, we would send a field technician to that location with the app to the center of the circle. They would do a spiral pattern. They would identify the exact location of the reef. And then they would take a picture, drop a flag on there. They would enter the parts per million in the app, and that's automatically uploaded to be tracked in the software. The good thing about that is operations-wise, as soon as the data is collected, just about, you can begin to remediate because you get the information on your phone and you can navigate to that location instantly. So what is the difference between OTM 51, which is compliance quarterly surface monitoring, and an emission study? Well, I mentioned kind of earlier, the Sniffer drone is a data collection tool. OTM 51 is a approved test method by the EPA. There's very specific calibration procedures that have to be done ahead of time. We've got to do a calibration of the methane detector. We also have to do a calibration check for how long gas takes to go from the bottom of the hose through the hose to the sensor. So that's all part of the calibration process. We've got to fly at the proper spacing. In most states, it's 30 meters. There's also site specific. Some states, California, Oregon, Washington, Canada, there's different spacing. Some of the states have tighter spacing, so we have to fly that. We have to identify and report anything that's over 500 parts per million, and it has to be repaired within a specific timeline. And it's a pass and fail event. You either get a go or a no-go. You either have exceedances or you don't, and those exceedances are either remediated in the proper timeline or they're not. And at the end, you get a regulatory report that provides you only the items that are specified in your Title V permit that had to be reported as part of the quarterly report. Because of that, it has limited value for gas improvement or renewable energy companies. Because if all you're getting is a list of 5 to however many points that are over 500 parts per million, that doesn't tell you what's going on across the whole. So it's required by the regulations. It's, there's a standard there. You meet that standard and you check that. Difference on an emission study is we're not just trying to meet a minimum standard. We're trying to identify almost every kind of emission that's coming out of landfill. So we're going to fly at tighter spacing, and we'll talk about that here in a minute. We're going to work with the site to determine at what threshold do they want to set our detection limits. Do they want it at 500, at 200 to 500, or do they want it at like 100? Some clients, we're setting our detection limits for checking at 50 parts per million. It just depends on the site. The great thing is there's no deadline for repair. So if we identify something and it's going to take you some construction work to finish, you've got as much time as you need to fix it without any regulatory issues. The data is confidential because we're not following the methods that you would follow for OTP21. It's just like the satellite or a drone flying over. There's no subpoena power. There's no regulatory hammer behind that. I'm going to take a second here to make an announcement that we're going to be going over in more detail at Global Waste Symposium next week. But we also have a new payload variant that's been developed that will allow you to even more put a barrier between emission studies and compliance, because we can set a user-defined threshold. For example, if your compliance limit is 500, but you don't want to see any readings that 500 or above in a study because you're afraid that they could get pulled for anything, we'll set the user-defined threshold at 450, let's say. And so it'll do the same pattern, but when it identifies things over 450, it's not going to record that number. It's just going to say greater than 450. So that would give legally, for people concerned about that, clear indication that they don't have it, can't prove that there's an exceedance or an issue. It's just, there's something greater than 450 that you have to address. So that's coming out this week, coming soon to a drone near you. The other thing that we can do once we do studies is we can provide unlimited ways to visualize and understand the data. We have interpolated maps, change detection maps, emissions quantification, welfare visualization, all sorts of tools that we can do to help you to collect the gas or to fix the system before you have a poorly compliance event. So now I feel this is the part where I do my best David Letterman impression and say the top 10 reasons for emission studies are. First of all, you can use emission studies to identify and repair emissions or locations before you have your normal quarterly set. And then also, second one, you'll have time to fix it. So if you have your quarterly surface emission monitoring, typically in the middle month of the quarter, say like in Q2, May, you fly a study in April, you get all the information of where all your leaks and issues are. You have plenty of time to fix them before your compliance event in May, and hopefully you have no exceedances. So what does that do? It means you might have fewer rechecks, because if you get a first time go and you don't have the 10-day and the 30-day recheck, you don't have to do that. You're also going to reduce the time in the field for your people and safety, because doing some is dangerous. And it gives you time to plan for repairs, and it overall improves your compliance reports and makes you look better as a facility because you have less exceedances. Number 3, compliance monitoring can miss hotspots or leaks entirely. And I will be honest with you on this one. At 30 meters, both a guy walking and sniffer drone is clogged in a mist. It's just because it's a pretty wide space, and you're talking about 100 feet between spacing. And this is kind of a visual example. If you're flying along on your serpentine path or you're walking along your serpentine path, if there's locations that are in between, and if the wind is going if the wind is going parallel to the path versus perpendicular, you'll never see it. And it's not a lick on the technology, that's just the facts of life. So you could miss stuff that you need to know about in order to collect for your renewable energy by doing only compliance center. So what we recommend, obviously, is when we do emission studies, we're flying them at least 15 meters. That allows you to get real good data for fidelity. We found that at 15 meters, we find just about everything. And we're pretty confident that 15 meters that we're going to identify units. And then that allows us also, with that amount of information that we collect, we can do a really good job of modeling and other things with that level of collection. So you say, hey, but Bill, I'm at a state that requires 25-foot spacing. Okay, well, if your compliance test is 7.5 meters, you better do your study at 7.5 meters, because you don't want to study for a test and then have it be twice as hard as what you thought. So we adjust our emission study spacing based off of a lot of factors. Our goal is 15 meters because we find it is the most efficient balance between finding everything and cost, because the longer we have to fly, it's just like anything, time and materials, right? Whereas, but if it's in a state with that tighter requirement, then we're going to fly it at a tighter spacing to make sure that you're ready for your fully compliance needs. Canada. Okay, we do a lot of work up in Canada. I mentioned we have a Canadian partner, and we have some Canadian friends on this call as well. Their regulation that's going into effect is a little bit different. They still do it at 30 meters, but they're offsetting the flight path 10 meters or the walking path 10 meters every quarter. So if you look at this, it's kind of hard to see, but if you look at the picture, the red would be quarter one, the dark gray is quarter two, and the light gray is quarter three. So in that particular case, your compliance is still 30 meters. We're still flying the study at 15 meters because we would be right in between those and we'd be able to identify everything. And then the last thing is greater fidelity. When we fly a study, we can see stuff down to really low levels. I mentioned that our sensor is good down to 200 to 250 parts per billion. Okay. So when we fly, we're going to see stuff that you would never see before. This example here shows, okay, you're flying along your path. There was an area that wasn't an exceedance or anything, but and you can see the two bright ones are obviously over 200. It was 144. You had another place that was 179. You have another place that's 101. You would never identify those and see those normally when you're doing surface emission monitoring for compliance. We did some work out in France, and they have tighter requirements in some aspects, and we were identifying locations down to 30 to 50 parts per million. They were going in the field and actually finding them on the ground. They were there. So we were able to really help you clean up emissions, because as you get the bigger issues down, we can start getting at lower and lower levels to continue to improve until you've eliminated as much as physically possible. All right, so what are some of the benefits? Well, emission studies, like I mentioned, provides you with a lot more information. This is the small sampling of the different types of reports we can do. I think the next slide talks through some of them. Obviously, we're going to give you the peak location report. That's also a report that goes in the compliance report. The yellow ones are 200 parts per million, the red are 500 parts per million. And that's going to give you where the leaks were and what the parts per million were in the grid in a table and everything. That's a standard report. The second one is an interpolator. And you can see that helps you to visualize not only high peaks, but also a bunch of lower level emissions. You're seeing emissions from 1 part per million up to 100%. As we fly a site more routinely, we can identify changes. So the third map here is showing you between two different emission studies. If it's red, the methane emissions have gone up. If it's blue or green, the methane emissions have gone down, and that helps you understand if your changes you've made in the well field or your construction or whatever, has it had the effect you have. And then the last one here is an example of a map we provide when we're doing emissions rate quantification. Those are virtual emissions locations, and Project Canary, our partner, is going to align our data up with those virtual emissions, and then they're going to move them around 100 times and use that to model where the emissions are, and also an estimated emissions rate in kilograms per hour or cubic feet per minute. And that's another report that we can provide once we get more data and we're able to So, number 6 reason, avoid nightmares. We've talked about the satellites, and the satellites are out there, and they fly over. It's pre-GHG sat. You've got the Carbon Mapper and all these different platforms out there, and every day they're launching more. And they give you what I call it the big blue blob. In this particular case, it's the big red blob. You get a big blob over your landfill, and then they put it out on the web as public information, and then regulators see it. You get regulators see it, your local community sees it, the EPA and your state regulators see it, and environmental groups, and then all of a sudden you have more attention than you want. Groups routinely are publishing like top 10 or top 100 lists of super emitters to landfills, and you can end up on that list and the whole world sees it. It's not good. The work we're doing in South America is directly a result of this. They got on that top 25 list, and they needed help, so they called us. So this is an example of how we can help. That's what you get from the satellite in the first panel. You just get what I call the big blue blob. You get a blob over your landfill saying, "Oh, you're a super emitter." We flew this landfill the same week. So we provided them with the interpolated map based off our data, which very much helps you to see in more detail where the emissions are. And then they said, "Hey, Bill, we want you to go out and manually verify." So we went to all those emissions locations, and we found 18 points on the ground with flags for them to fix in order to remediate that big blue blob. So the difference between us and a lot of their technologies is if I don't give you something you can action in the field, we aren't doing it. And that's the purpose of an emission step. Okay, number 7, odor complaints. You get the big blue blob, you got a lot of emissions, your neighbors are probably smelling it, and you're going to get odor complaints, which if everybody's been at a landfill, you know how awful that can be if you have the state and the EPA and everybody else up here, you know what, with a microscope. So we assist with that. We fly emission studies like we normally do, and we drop our detection levels down to 50 parts per million or so, depending on what the client wants. Then every location that we see those 50 parts per million, we're going to go to that site, check it for methane, and we're also going to check it for hydrogen sulfide. And there's about a 70% correlation between, yes, there's a methane emissions point here, and oh yes, there's a hydrogen sulfide. So that allows you to pinpoint the exact locations of your emissions so you can fix them. If you give us your well field data as well, we can pull that in, and we can we can map the hydrogen sulfide in your wells, correlate it with these leaks, and do a lot of cool visualization to really understand where the problem is, and then kind of help you come up with a plan to fix that problem. We do quite a bit of work on the odor study side, and we are in the process of developing a specific sensor for hydrogen sulfide, but probably maybe more the end of the year, early next year before we'll be able to do it. And number 8, you can avoid consent orders. If you're only doing quarterly monitoring and you have problems at the site, you're probably not getting the information you need to remediate. And this is kind of a cost benefit on that. So the first 2 are the cost of compliance. You have your normal initial, your normal surface emission monitoring. A lot of places are going to charge you per recheck. So if you have an initial and 2 rechecks, you're gonna, you can have up to 4 checks per quarter. So that's going to have a cost associated with it. And then if you do us as a study, there's a cost to that. But the cost of consent orders can go through the roof because you can have potential fines. You're going to have court order enforced additional monitoring. You may have court order enforced construction, which is going to be under the gun. So you're going to have to pay for expedited, drilling and this and that and the other. So the costs all go up. So by doing studies, you can get the information to remediate before you get into this situation. And if we're successful in our studies to help you remediate, you potentially could eliminate rechecks if you get a first time go on the SEM, and that's going to help pay the cost of what it would cost to do studies. I'm not saying always will, but it can. So those are some important things to think about as far as costs. And then another big thing is increasing gas collection. Number 9, increasing gas collection. We do a lot of work with RNG companies. I would say 75 to 80% of our work we do is emission studies for RNG companies. The reason is we help them find gas and we help them not waste money. That's the bottom line. This is an example of a site that we did a while back now, but the north area is the NSPS area. The south area is non-NSPS, but they're still filling down there, and they needed more gas to make their RNG project profitable. They were going to spend about $750,000 in that north area with the oil field expansion. And we showed them there was almost next to no gas to collect. You can see there the estimate was about 110 SCF. We have shown over and over again, if the whole screen is blue like that or purple like that, and you put wells in, you're not going to get additional collection because you're already collecting. So they looked at the bottom area there, and of course, there's a lot more available gas, 750 SFN. So instead of spending $750,000 in the north area, they reallocated the resources, and they're going to be putting horizontal collectors and other things in the southern area to collect the gas in order to get what they need for the plant. So they didn't waste money where it didn't need to be, and they're putting it where it's going to actually help, which is going to help them improve their collection. So the other thing we can do is if you provide us with the well field monitoring data. Now, I'm not saying this is like a big database where we're tracking all of your compliance data and we have your well field data for the last 10 years. That's not what this is. This is a snapshot of it. You provide us the well field monitoring data for the month that we're there to fly the study. And then we'll pull that in GIS, and much like we can do with interpolated mass for methane, we can do the same thing for well field parameters. In this snapshot, you had some emissions down here, and those emissions were all in the 150-ish range. And when we pulled the well field data in, there was that whole header had lost vacuum. The available vacuum was about 25 inches of water quality. The vacuum available on these wells was about 6. And by repairing the header, they would be able to collect additional gas. We can do that with all the different well field parameters, and we also, for temperature, we can look at temperature. We have hot temperature wells, the hydrogen sulfide for safety. There's a lot of different parameters we can pull in and do analytics on to help you to improve your gas collection and to know what's going on in your system. And this is the case study of a landfill that we did. We've been flying this landfill for 2 or 3 years now. And it was a program. It wasn't just a one-shot and kill. We go out and the world is great. We flew it in January as a baseline. They were getting ready to do construction. At that time, the emissions that were calculated to be about 300 SCFM. And understand, 300 SCFM, that's SCFM of methane, right? Not of landfill gas. So you're talking probably 600 SCFM of landfill gas was emitting from the surface. They used that data that we gave them from the first flight, and we also pulled in the well field data and everything else. And they used that to improve the system. You can see along the edges here, there was a lot of emissions along the edge. They spent some time on cover integrity along the edges. And then in the middle section here, they used the information we gave them to look at wells that might need to be pumped, but also reallocating the locations of wells that they had planned better match where the emissions were. And then the second one was kind of midstream. They were still under construction. But the third pane here in March, they were done with construction. So you can see after using us to help them, the whole area was cleaned up except for this one little square down here. Right? Well, that one little square down there was where they were actively filling. They were going back and forth across that area. Every month they'd move a little bit or whatever. So they couldn't put some vertical wells in. So they installed a bunch of horizontal collection in there, and then they cleaned it up to this level. And you can see through, as we do more data, you can do data trending. You can see the average SCFM emissions trending down. Average parts per million emitting from the landfill trending down. Number of individual exceedance locations trending down to 0, actually. And through that, they went from 1,500 to 2,000 SCFM at the flare. That gave them about 200 SCFM of product gas. And the numbers always change with the markets, but that's about $1.5 million of revenue. So we can help you improve your gas collection, reduce your emissions, and improve your ROI for your renewable energy. And reason number 10, it's just the right thing to do. Regardless of where you sit on man-made climate change or global warming or any of it, Landfill gas is a pollutant, does stink, it's bad for the environment, right? So the better we can collect it and get it into the pipeline to make money, the better off everybody is, and it's just the right thing to do. We've seen these numbers before. I will post out though that landfill emissions are the third largest methane emission source in the United States. Oil and gas is number one, dairy is number two, and landfill gas is number three. Well, we work in all three of those sectors. We do some work, a little bit of work for abandoned oil wells in the oil and gas. We do a lot of work for the RNG companies that do dairy and swine biogas, and we're very obviously developed for that. And yeah, we do. And this is just kind of an example over time, right? We've been doing one site for years, and they were under regulatory scrutiny, and they were trying to document that, hey, we're actually doing a good job. We're getting better. And because we have so much information, because we can track it over a long period of time, we could show with data that their emissions are continuously decreasing over time. And they use that as what, one an argument when the regulator said, you're not doing anything. It's like, look, we've reduced our emissions significantly. All right, so I'm going to transition a little bit here. That's kind of why you would do compliance is over here. Why would you want to do methane studies, even if you're already doing compliance? And then the question is, how can you do it, right? One way you can do emission studies is, hey, we come out and fly a study for it. We'd love to do it. We do it all the time. We got pilots that could fly all over the country and all over the world doing emission studies. But if you're an engineering firm and you have several, lots of sites you do, or if you're an organization that has multiple sites that you're going to be doing on a regular basis, maybe a partnership program is what we need to do. That allows you to fly the stuff yourself. You're going to save money on the cost to us, and you're going to have access to the information whenever you need it. So the way that works is, we get with you, we can do a product, we can do a demo at a site if you need. We'll sign a contract, we deliver the payload. We'll come out and train your pilots on site, make sure that they're good to go with the procedures and everything. You provide your own drone. And then after that, you collect the data, you fly it and everything. The data comes to us. We we manage the software. We manage the reporting and the data analytics. And you pay for those, but you don't pay for the drone itself, for the payload itself. And then obviously we provide you with the deliverables, you package them up and give them to your clients, and then everybody makes money. It's really great. The other thing to mention is you provide your own drone, so you have to have an M300, M350, or M400 in order to fly it. So it's a pretty simple process. It allows, first of all, allows you the access to the technology at a cheaper cost. Allows us to scale because we can get it in the hands of more people and get it across America in order to get OT-51 usable. On the compliance side, on the emission studies is a no-brainer. On the compliance side, there's been reluctance to do OT-51 for various reasons, but it's just a better way to do business. I mean, I can't say it any better. You aren't putting a guy or a girl out walking landfill in harm's way, for 50, 60 miles on a 3-to-1 slope. So the more we can get people to stop doing it that way and use technology. All right, so some recommendations. Obviously, one study a year, probably in the spring, gives you a good idea to plan for when you're getting ready to do construction projects. That's good. Better, maybe a couple a year. You're doing your Florida surface emission monitoring, or if you're not on a SPS site, you're not. But if you do one in the spring and one in the fall, typically your construction periods are spring and fall for the most part. And it starts to give you data where you can trend over time and figure out what's going on. Obviously, the more data you collect, the better. So quarterly studies is the best way to do business. And a lot of our clients do quarterly studies. And if you're NSPS and you're doing surface emission, you offset it a month from when your actual SEM is. And that allows you to be ready for when that happens. And now in Canada, you guys obviously have different requirements. You're not flying at all in the winter. We don't fly in Canada from like December through February, pretty much. So, obviously 1 to 3 studies a year. We're going to do it in, starting after March typically. And we're going to do it at 15-meter spacing so that you can collect the data you need for the regulations there. And then I'm a big fan because I'm a gas guy and I've had to deal with, spending a bunch of money on a gas collection system and then not seeing a return on that, getting nothing. So I believe you need to do a study before you, in the design process, you do a study before you finalize your construction. You use that data to inform your construction, adjust wells, figure out what wells need water to be dewatered. Areas that really, okay, maybe there's issues, but you're not going to get a return. You could defer those. You make decisions based on data so you can maximize the use of your capital dollars. And then afterwards, after you complete it, you fly it again to make sure you got the results you want. Did you reduce the emissions? Did you see increased gas in the pipeline? We reduce some of those issues. So those are kind of ways that I would use our technology going forward. All right, so key takeaways. First of all, emission studies are confidential, they're non-compliant. So if you can remember anything, method 21, OTM 51 do not equal sniffer drone or emission studies. Those are a separate category of events, but you can use those to improve your gas collection and improve your compliance with it. Using studies can help you to reduce financial impact when you do have enforcement things. You're not going to, you can possibly avoid them because you never have the issues, but you're also not doing work under a regulatory gun because you had been addressing that issues as they come up. And one of the biggest, obviously, factors, which is why 75 to 80% of our business is in the RNG world, is you can increase the profitability of the product by doing studies versus compliance. All right, I'm going to hand it over to Rob here for a couple sales announcements.
All right, thanks, Bill. And just a reminder, if you have any questions, submit them through either Q&A or chat. It's being a little temperamental, but it looks like I have chat enabled now. And I also have, if you want to turn on your camera or your mic, you should be able to do that for the Q&A section. We just ask you to raise your hand and then we'll call out on you. But I definitely want those questions. And yeah, so some things that we can do to help you, right? As a thank you for attending this webinar, we'd be happy to offer a 10% discount on any study that's booked in Q1. So my ask on that is that something, just contact me, sooner than later, and we'll get that process started. We're also always happy to work out discounts for longer term contracts, whether that's annual contracts or multi-year contracts. And, so why do we do that? It's really a win-win. It gives us a lot of ability to plan better, to control our travel costs. So, that makes a lot of sense and can save you some money as well. So again, let's have those discussions. And then, finally partnering, right? So Bill mentioned around partnering that, if there's a minimum requirement for, the amount of work, but maybe you already have an environmental engineer that you're working with, and that we'd be happy to work with them as a subcontractor, or maybe you could set us up and we could have that conversation with them, giving them access to our technology. So we're certainly not looking to compete with them. We're not asking you to change service providers, but we could potentially partner with them. To that point, Bill, if you could go to the next slide. Our next webinar is going to be Friday, April 3rd, and we're really going to get into the nuts and bolts of the partnering program, our methane analysis partner program. And so I'll share that registration link in the chat as soon as I'm done with this here. So you have that. I'll also follow up via email. And again, just some requirements you think about. Am I, a right fit for the partnering program? So we look for our partners to operate a compatible drone. Currently it's the DJI M300, 350, and 400. Soon to be US made drone. We're working on that as we speak. You'd be required to either subcontract or employ an FAA Part 107 certified pilot. That's of course for the US. Any other jurisdictions, certainly want to comply with the local regulations. Again, as Bill mentioned, we're looking for partners to fly a couple missions per month, right? The last thing we want to do is part with the payload and have it sit on the shelf when it could be deployed out there, generating revenue for the company. So if you operate one site, then it may not necessarily be a good fit for either of us. But multiple sites starts to make a lot of sense. And then certainly, some business development opportunities. We do work with our partners to provide, some market intelligence and leads, but ideally they would also have their own book of business as well. If that's of interest to you, we'd love to have you join our next webinar, where we'll really go into the nuts and bolts on this. And then the last thing, we have Q&A.